These are pre-algebra notes for section 2.4 where we are going to compare proportional relationships. So in 7th grade, you spent a lot of time looking at using proportions. And now we're going to do the same thing, and we're going to start with something you're used to. Looking at prices of items. So we're going to take our these images and show how much is the price per unit. So we're going to do that and determine the better buy. And we're going to do that by finding the cost per ounce. So that means we're going to put dollar amounts over ounces. And so for this first bag of Tostitos Party Chips, we're going to put $6.14 over 14.5 ounces. And of course, we want you to use a calculator for this. So 6.14 is going to be divided by 14.5. And I'm going to use that decimal 0.4234, so 423. So we'll round that 0.42 cents per ounce. And this size bag, it's a different size, different price. So we're going to find the price per ounce. So 438 over 10. This is 438, so that's about 44 cents per ounce. So the one that is cheaper is the one that costs less, or the better buy. So that one is cheaper. Okay, Takis, one of middle schoolers' favorite snacks, or at least it was when we made this. We're going to find when it's $9.99 and you're getting 18 ounces. We'll divide that by 18, so that's 0.555, which we could round to 0.56 per ounce. And this bag, $3.78 over 9.9, $3.78 divided by 9.9, 0.381. So the better buy by quite a bit is this bag because it costs less per ounce. I forgot to put per ounce there. Okay, these Jolly Ranchers, it looks like they're on sale for $1.83 for a total of 7 ounces. So $1.83 divided by the units, so our 7 ounces, is 0.2614, so 0.26, so 26 cents an ounce. And then we've got a bigger bag, that's $3.74, and you're getting 14 ounces. So that's, whoops, let's drag that over, 0.267, so 0.27 cents per ounce. And these are really close in price. The 2614 and 267 tells me that when these are on sale, they're the better buy by about a cent. So it's not very close. All right, moving into the 8th grade portion, we're going to graph lines in this next section. This is one of the most important things you're going to learn in 8th grade. So a linear graph is a graph that makes a straight line. Inside that word linear is a line. Okay, we're going to use X and Y when we graph. The unit rate is a ratio that compares two quantities, and the denominator has to be 1. So 500 miles per hour, that might be how fast an airplane travels, but notice that it's 1 hour. The constant of proportionality when two variables are directly proportional to another. So we can use this equation for y equals k times x. K represents that constant of proportionality, and later on we're going to call it by another name, slope. And a proportional relationship is a relationship between two quantities when their ratios are equivalent. So if you pay $30 for $10 of gas, you would also pay $18 for 6 gallons of gas. And we can see this in a table, in a graph, and in an equation. So here we start with Mira is researching the cruising speeds of different airplanes. Which airplane has the greater cruising speed? So we can see that we're going to measure this Cessna over this Boeing 747. And when you're measuring speed, we want to know miles per hour. And we're actually using kilometers. Oh, not hours, so I'm totally wrong. Let's fix that. We're going to measure the kilometers per minute. So I can see that for this Cessna, so that's like a little plane, we've got 40 over 5, and that simplifies to be 8 over 1. We've got 120 over 15. Let's see what that simplifies to be. I'll pull up my calculator. 120 divided by 15 is 8. So that's the same as 8 over 1. So I'm using each individual relationship. 240 over 30. Well, 30 goes into 248 times. So I'm sure you're noticing a pattern. 360 divided by 45 is 8 over 1. So these are all simplifying to 8 over 1. 480 over 60. Well, 6 goes into 48 8 times. So that's 8 over 1. So they all simplify to 8 over 1. Okay, so that's 8 kilometers per minute. And the Boeing, we want to find perfect point if we can. So that first dot on the graph, not great. The second one, not great. But here I can see at this point, I've gone 60 kilometers. And I've done that in a total of 4 minutes. So 60 kilometers every 4 minutes simplifies down to be, 60 divided by 4 is 15 over 1. So that's 15 kilometers every 1 minute. Okay, so now we're going to just fill these in. The Cessna, the little plane, has a cruising speed of 8 kilometers per minute. The Boeing 747 goes 15. So the greater cruising speed is the Boeing 747. Okay, now we're going to do the same thing. This says the graph represents the rate at which Mario makes origami birds for a craft fair. The table shows the rate at which Josh makes it. Okay, so we've got two different people making birds. So we can see Josh on the table and Marlo on the graph. Who makes birds at a faster rate? So that's our question. And so we want to look at Josh. 2.5 birds in 1 minute. And that's consistent across the table. So 5 over 2 would be 2.5 over 1. 7.5 over 3 would be 2.5 over 1. So I can see that this rate is consistent across the whole table, 2.5 over 1. So Josh's rate is 2.5 birds a minute. So he is making birds really quick. Let's look at Marlo. And here I can see, I'm going to use a perfect point. And I want birds per minute. So this dot shows me a value of 4 birds every 20 minutes. Well, 4 over 20 would simplify to 1 over 5, which would be a fifth of a bird. So Josh is moving much faster. If you were to graph the data for Josh and Marlo on the same coordinate plane, how would the two lines compare? Well, Josh's line, he would be making, let's see, could I fit that on there? I wish I could show that. Josh's line would be a lot steeper. Okay. Now we're going to compare Daniel and Brianna. This says the graph on the right represents the rate at which Daniel earns points on his video game. The rate which Brianna earns points is represented by the equation. So Daniel's on the graph. Oh, she gets 2 N's in her name, Brianna. So y equals 2x. And this says where y is the number of points and x is the time in minutes. So every 1 minute, she's going to earn 2 points. Now, Daniel, it looks like, oh, we can see here, in 1 minute, he earns 3 points. So the ordered pair 1, 3 represents Daniel's unit rate of points per minute. So he earns 3 points in 1 minute. Brianna earns 2 points in 1 minute. So who's going to get there first? Daniel, because he's earning more every minute. Daniel will earn 100 points quicker. All right, now the graph represents the cost per ounce of a granola cereal. A 15-ounce box of raisin cereal costs $3.90. Which costs more per ounce? So the graph has the granola cereal, and then the raisin cereal. We want the price per ounce. So $3.90 for 15 ounces. And we're going to simplify that with our calculators. $3.90 divided by 15. So that's 26 cents for every 1 ounce. And on this, the granola cereal, I want to use a perfect point. Okay, we don't want you guessing where these values are. So we want to use that, let's see, this is the only one here that's a perfect point, and that's 20 ounces, and it's $5. So we want the cost per ounce. So that's $5 over 20 ounces. So let's take our calculator and do 5 divided by 20 is 25 cents per ounce. So these are really close in price. The question is, it's not asking us the better buy, is which cereal costs more per ounce? The raisin cereal. Okay, the last one says the distance covered by the fastest high-speed train in Japan traveling at a maximum speed is represented on the graph. The fastest high-speed train in the U.S. is traveling at a maximum speed of 600 kilometers in 2.5 hours. So we're going to simplify that and then do the same thing using the graph. So let's start with the rate of the U.S. train. 600 divided by 2.5 is 240 kilometers per hour. And over here, the Japanese train, I can easily see that it's 1 in 1 hour. It can go 350 kilometers in 1 hour. So, which train has the greater max speed? It's the Japanese train. So the Japanese train has a greater max speed than the U.S. train. Okay. All right. That's it for these notes.